So let's do it and let's start to learn MATLAB. The first thing you need to do is make sure that MATLAB is installed on your computer first, and once MATLAB is installed, then look for this icon on your desktop. If you don't have the icon on your desktop over here, then come down here to the Start menu, click on the Start menu button, and then look for the icon for MATLAB. If you don't have this icon over here, then what you do is go back to All Program, click on it, and then look for MATLAB directory. So the MATLAB directory is over here. If you don't have the MATLAB directory, that means the program is not installed or something wrong with the installation. So talk to somebody like maybe your technician, your IT technician, to reinstall MATLAB for you. But what you do is, if you have the directory here, click on it, and I have another directory here, I would click on it, and then I will click on MATLAB here. In my computer, I have 3 icons. One will activate, one will deactivate, and one will load the program. This is Windows 7 version, 64-bit microprocessor. So it might be a little bit different from your computer. I will double click on this icon, and by double clicking on this icon, the program will start loading. It usually takes like a few seconds to load the program. That depends on the speed of your computer. So if your computer is fast, it will upload the program and it will be running fairly quickly. My computer has a lot of software installed in it, and it is a little bit slower than the super fast computers. But by any means, I have my MATLAB main window is uploaded. And if you look into the program, this here is the main window, and this main window has 4 small windows. There is a window here called the current folder. This is the command window. This is the workspace, and this is the command history. So depending on your version, you might not have all these 4 windows, or you might have all those 4 windows. But if you have the same version and you don't have all these 4 windows, so let me just close those windows, and I will only have the command window over here. So if I have the command window and you want it to look like the way I showed you, then come to this desktop menu item, and then go to desktop layout and click on default. So desktop layout, then go to default, click on default, and then you will have the defaulted 4 windows. Honestly, this middle window, the command window, is the most important one for us, and I will show you what's the other 3 windows. So before we do that, let me explain that this is the main window over here, the main window for MATLAB. Over here we have the main menu. So the main menu basically is a classical layout for most software. This first menu item called File, then we have Edit, then we have Debug, then we have Desktop, then we have Window, and we have Help. The second list of tools is what I call menu tools. They are basically shortcuts for some of the window items that exist in any of those window items. For example, when you come to File, what we are interested in is a new file, open file, and then exit MATLAB. Later on, we can use a print. Preference is basically will set up your layout preferences for the software, how it runs, how will it look like, how you would like to run it. It's a little bit advanced, but you might use it later on. Import data might be important for some applications, but for now, what we are interested in is the new, the open, and the exit. So they have shortcuts here. You have the new and the open, and you can close or exit the software by clicking this icon or this button over here. The edit is very much classical, so there is the undo, redo, cut and paste and so forth. But there is three more commands at the bottom. They call the clear. Clear command window, for example, it will give me an option. I will say okay. What it will do is it will clear the command window for me. So if I go to edit, a clear command window, it will clear the command window for me. And then if I say a clear command history, what it will do is it will clear the list of the command histories. So this particular window will list the command history that I will enter into the command window. I mean, it might look a little bit confusing at this point, but as you start to use the software, you will see what I'm talking about. So I'm going to clear it just to show you. So you see that it cleared it. It just gave me the last command history, which basically says that clear the command window. So that's what the clear command history will do. It will clear our commands. And then there is another one. It says clear workspace. And that's basically all the variables. I will clear all the declarations of the variables we use. And we can show you that in a little bit. So don't get confused in it. But basically, the three clears says a clear command window. Then you can clear the command history, and you can clear the workspace, and the workspace has all the declarations of the variables we use. The debug is a debugging tool. I'm not going to use it now. We will use it in later lectures where we will show you how you can debug your code, because this particular lecture is very basic lecture. We are not going to do a lot of debugging here, but you will use debugging probably when you start to look at loops and you start to look at conditional statements like the if then statement, or at the loops like, for example, the for loop. You start to have some logical errors in your code, because there's two kinds of errors that are very common in programming. One is called syntax error. The syntax error is very easy to debug. The debugger will tell you the syntax has some error in it. But there is another kind of error called logic. Logic means that you write the code to do a certain task, but the logic used to implement the task is incorrect. So that's called logical error. Logical errors are very hard to detect. So when the programs get complex and you have a logical error, you want it to go through every step in your program to verify the logic of every step. So it is faster for us to use debug tools, and we will use it later on in this tutorial. The desktop basically will talk about some of the things I talked about, like clearing the command windows and so forth. And it will show us different windows we need to have in the different layouts. So this is the windows. It shows you basically the four windows we have: the command window, command history, current folder, and the workspace. I don't use those as much, but you know, you might use them if you want to, but they aren't as important for me, at least at this point. Then we have the help. We're going to use the help a lot. Especially, I can write the help in the command window. I will show you that shortly, or I can use the help by clicking on this icon, the shortcut. So the shortcuts I have is basically I will have a new script, open file. I will do cut and copy and paste, undo, redo. This is a very important tool in control engineers, even though I will not cover it in this tutorial this particular tool called Simulink. Simulink is a special tool built on the top of Matlab. Uses basically something we call block diagrams. So you design control systems graphically by using block diagrams. I don't like to use it, however it is very popular among control engineers. I like to use hardcore coding, writing codes. The reason is I do a lot of software as well, so for me it is much easier to write codes than to do simulation graphically. But there are many people who can argue my argument, and I agree with them. This is basically to design GUI, because modern MATLAB can provide GUI, graphical user interface applications. So if you want to design GUIs, you can use this. This is a very nice tool called the Profiler. When you design a code, and if the code is very complex and there is part of the code that is basically the bottleneck of the design, that part of the code is very inefficient, very slow. So Profiler is a tool you can use to test what portion of the code is very inefficient and how could you optimize that code. Then you can go back and optimize that code to make it a little bit faster. In control, or at least in control theory, the classical theory wouldn't use Profiler as much. Most of the things that we're going to learn will be very straightforward. As I said earlier in the previous discussion, our task is to learn that design is an iterative process. So we have to iterate our design and tweak the parameters to make it work. And that's why MATLAB is useful for us, because we will be able to only change one parameter once and then it will give us the right answer. Or you can write a for loop, for example, or a while loop to go over a range of iterations automatically, and it will be able to spot the solution for you automatically. It might take you some time, like few minutes, but you will be able to solve or design the system according to the specifications. So I think this is all what we're going to cover about the layouts. So it is very good. It is a very good time for us now to start writing code in MATLAB. So what we're going to do next is we are going to learn what we're going to do in this particular window. So at the command window, I will write A equals 1. The first thing we're going to learn now is we would like to learn very basic functions. It is a very good time for us now to start writing code. And one of the things I wanted to do is I would like to start with basic functions and basic scalar variables and scalar operations. So that's the first thing we're going to do. Basically, we will learn scalar variables and scalar arithmetics. So let me show you how we can use that on MATLAB. So this is called the command window. I will come to the command window and I would like to declare a variable. I will call it A. So A equals, for example, 2. So A equals 2. I will hit enter. This is a command. I'm sending a command to MATLAB. I will say allocate a memory location for me, call it A. That memory location that's called A is a variable, and I will assign a value called 2. So, and this is a programming thing that we know, right? So when we say x equal 5 in programming, what that says is basically allocate a memory location, call it x, and then assign the value 5 to it. Over here, we say that A equals 2. I allocate a memory location, and I assign a value for it called 2, and this memory location is named A. Now what MATLAB do is it will echo the content of that variable. So it will say that A equals 2. So let me, for example, say another variable that is called B equal 5. Hit enter. It echoes B equals 5. You see that? So let's go back over here and let's look at the workspace. At the workspace, it shows me that there is two variables, A and B. The values are 2 and 5. So the workspace window will show me the memory declared values or variables and what's their content, and also it will show me the minimum and the maximum, so it shows you those values for them. Also, if you go back to the history command, it shows you the commands I listed, because you see I have a command, then it's echoed, I have another command, then another echo, so I have 1, 2, 3, 4 different lines, while the command history are only 2 commands. Now, echoing the data is helpful because you want to know the answer, but at the same time it is annoying, because if every command I'm gonna write, it's gonna echo it, it's gonna repeat it. Echo means repeat. It's gonna echo or repeat the value of that command. It becomes annoying. So if I do not want to echo that command, I would say, for example, A equals 2, and I will add a semicolon. So this is very important here. A semicolon means do not echo this command. When I hit enter, it doesn't echo. I'm ready for a new command. And you can see that in the history, command history, I have A equals 2. So this will give you a sense of what kind of commands I have given to the command window. So those commands are called scalar values, and scalar values can be positive, can be negative. So I can say that A will equal -2, B will equal -3.5, semicolon, and that basically here is a real value. So it can be integer or it can be real value. Now keep in mind that MATLAB by default will assign it as a floating point arithmetic. So it will use 32-bit memory location for each variable. It does that by default. So if you wanted to have it longer, we will learn this later on, you can define it as a double, or you can define it as an integer, or you can define it as 8-bit integer or 16-bit integer. So we can do that if we want to, but this is a little bit advanced for this particular tutorial, because in control we mostly deal with floating point arithmetics. Other applications, especially when it comes to DSP, digital signal processing, you need to deal with finite length words. So we don't care about the finite length precision and control in the early stages in the classical theory. When you implement things on microprocessors, you need to make sure that you are using finite length words, and you can do that with MATLAB. So we are not going to worry about the variable length of MATLAB at this moment. We are going to assume that it will take either integers or floating point arithmetics, and it does that by default. So by default it is a floating point arithmetic which includes integers as well. So now that's what we have. We can also do some arithmetic operations. So let me clear the workspace, so we clear everything. So I'm going to come back to the edit, and I will say that clear workspace, say OK. So when you clear the workspace, basically it clears all the variables. So if I say A, it tell me that A is undefined. There is nothing that defines A because I cleared it, right? So a clear workspace, basically what it says is a clear all the memories used for declaring variables. Those variables are erased from the memory. Clear workspace, yes. And then I'm going to also clear the command history, yes. Then I don't have any command history here, you see it is cleared. And then finally I will clear the command window, and then now I have a new window. So let's start all over again, and now what we are going to learn is how could we use scalar arithmetics. So when we use scalar arithmetics, I will say that A will equal to 2.5 semicolon, and B will equal to 3, let's say minus 4. So A equals 2.5 and B equals minus 4. Now what I'm going to do is I would like to do some addition. So I will say that C will equal to A plus B, and I'm not going to have a semicolon. If I don't write a semicolon, it's going to echo the answer. So A plus B will be minus 1.5, as you see here. And that makes sense because 2.5 plus the minus 4 is minus 1.5. Let's say that I want to do subtraction. D will equal to A minus B, and let's see what we get. 6.5, right? Because 2.5 minus the minus 4 is plus or positive 6.5. Let's say that I wanted to do multiplications, so I will say E will equal to A times B, and that will give me minus 10. Let's do division, so I will say F will equal to A over B, so that will be minus 0.625, which is roughly is that 1 over 8, or no, it's not 1 over 8. 2.5 times 4 gives me 10 over 16. 10 over 16. Okay. 5 over 8, that's what it is. Okay, so minus 5 over 8. Anyway, so this is basically how we can do basic arithmetics with scalars. Let me first of all clear the command window. Now, another important thing that for us we need to have is that we can also use things like the cosine of an angle, right? So let's say that I wanted to know what is the cosine of pi. The cosine of pi should be minus 1, right? So you can say the cosine of pi. I can say the cosine in degrees of 30 degrees, right? Or the cosine in degrees of 60 degrees. So there is all those functions that we know, the trigonometric functions, the exponential functions, the log functions, the absolute value. I can say the absolute value of b. I know that b equals minus 4. It is already stored for us here. B equals minus 4. So now I want to say that what is the absolute value of minus 4? That is 4. What is the absolute value of A? A is 2.5. It will be 2.5. So there is an absolute value also of a value. If I wanted to know the list of all the functions, those basic functions that MATLAB supports, I have to rely on the help menu. So let's do the help menu. Let me clear the command window. And now I will use help. So help will give me a long list of toolboxes. So when you write help, you get a long list of toolboxes. This is all our toolboxes. Those are not functions, those are toolboxes. So MATLAB supports a lot of toolboxes, or what we call libraries, right? So those are libraries, and each one of those libraries have a lot of functions in them. So for example, you can say general, this will have general purpose commands, ops that deals with the operators, the toolbox slang that deals with programming language, LMAT, that's elementary matrices, rand_fun, that's random functions, usually applied to matrices. Then this one is what we are dealing with, or what we like, is LFun, that stands for elementary functions. So this is elementary math functions. So let me click on it. When you click on it, you move to the elementary math functions, and it shows you all the functions that we have under this toolbox. So under this toolbox, we have trigonometric functions, all those trigonometric functions. We have exponential functions like the exponential, we have the log base 10, this is exponential, this is log base 10, this is natural log is log base 2, this is power base 2, then I have real power, then I have square root is very important. So those are very most common exponential functions that we use in electrical engineering. Here it deals with complex values. I will cover complex values shortly, but you can get the absolute value of complex value. You can get the angle of, or the phase of the complex value. You can get the complex conjugate. You can get the imaginary part, imaginary. You can get the real part. And then you can say is real. Those are the most important complex functions that we use. There is also rounding. You can use fix, floor, seal, round, mode, the reminder, and the sign function. So those are different functions, very common functions that we use when we develop algorithms and control theory, for example. And if you wanted to know, for example, how to use a sign function, you click on it, and it will give you a document here that reads about it. So basically the sign here, it says sign of an argument in radian. So sign of x is the sign of element x. I can also write it like this. I can say help sign. When you do that, it will repeat the help document for the command sign. I can also say, for example, help exp, that's the exponential. So, and exp is basically the exponential, and it says exp of x is the exponential of element x, or basically it is e to the x, right? So let me now clear the command window, and let me clear the workspace. And now I would like to explain again that x will equal to 2.5, and I'm going to have a semicolon. Now I would like to say that b will equal to the exponential of x and I put a semicolon. So b equals to the exponential of x. If I want the value of b, all what I have to do is just type b again, and it will repeat for me the content of b, which is the exponential of x. So I can say that b will equal to the exponential of x, and it is 12.1825. So if I declare a variable like y will equal to 5, and I have a semicolon, and now I wanted to recall the value of y, I just type in y, and it will give me the content of y. What we're gonna do next is we're gonna introduce the complex values. So how can we write complex numbers in MATLAB? Let me clear the command window, and now I'm gonna say that x will equal to, I want to enter a complex value. So the way I would write it is, let's say the complex value is 3 plus 5i. So I will say that 3 plus 5i, and when I hit enter, MATLAB understand that this is a complex number, and it will give it to you as 3 plus 5i, where I is the imaginary operator, which is the square root of -1. Electrical engineers like to use J as an imaginary operator so that we don't confuse the current with square root of -1. I can also use J as an imaginary operator. Instead of writing I can use J to mean the square root of -1. Remember that mathematicians like to use the square root of -1 to be I, but electrical engineers like to use J so that we don't confuse I, the current, with the imaginary part or the imaginary operator square root of -1. So I can say that y will equal to, let's say, -2.5 minus 3j. So j is recognized by MATLAB to be the square root of -1. However, it will code it as the operator I. I can apply the same elementary functions that I used to the complex numbers. So I can say that z will equal to the exponential function of x, and z will be a complex number because the exponential value of x, where x is a complex number, then the exponential value of x will also be a complex number. I can say the cosine of x, it will also be a complex number. I can say the sine of x, it will also be a complex number, right? Those all mathematics are used by using Euler identity and substituting for the cosine and the sine as in exponential functions, but the exponential function is always a complex number, so they kind of work together, and the mathematics is accurate. When we come back in the next part, we are going to look at vector arithmetics. We're going to look at matrices arithmetics, and then we will do plots or graphs, and then we will do functions, and that will be the end of lecture 1.